In this video, we are going to study section 2 of chapter 2, and this section is going to be definitely the most important section of this chapter, and it's also the most important section for the first exam. I expect most of the questions in exam 1 coming from section 2. Okay. The goal in this section is to price level annuities. By price or by pricing, I mean we want to know the equivalent value of a sequence of payments. We begin with annuity-immediate. So again, what is annuity-immediate? It's a sequence of payments that are made at the end of each period. And of course, our standing assumption is that the payments are leveled, or the payments have the equal size, and we can even assume the size is 1. Of course, if the size is something different from 1, you simply times by that number, right? So if I'm going to receive an annuity with equal payments $100, well, I will use 100 times whatever the thing we calculate in what follows, okay? So again, here we consider annuity-due, annuity-immediate. So it's a sequence, or it's a series of n payments with equal payments to be 1, and all of them will be made at the end of each year. I should mention that when I say year, it does not need to be the physical year. It should be a period. So it will be the unit time period you choose in your study. Since we often consider year as the unit period, that's why I sometimes, or from time to time, I will say it's being made at the end of the year or at the beginning of the year. Okay. Denote is present value. So it's the present value denoted by A angle N. So that's that is how you pronounce. Of course, it's A angle N at I if you want to call. And N is the number of payments. I is the effective annual interest rate. Effective annual interest rate. So we have this nice formula to calculate the present value. So present value is the value at 0. So first, let me draw a graph to help you understand what's going on. 0, 1, 2, 3 goes all the way to n minus 1 and n. By the way, when I draw the timeline, 1 means the end of year 1, or the end of period 1. 2 means that is the end of year 2. 3 is the end of year 3. So each number denotes the end of that period, okay, not the beginning. Okay. So I'm supposed to receive $1 at time 1, 1 at time 2, 1 at time 3, and so on until year end. So in total, I will receive n payments. All of them will be made at the end of each year. I want to know how much this series of payments is worth of at time 0. So present value really refers to the value at 0. So this is the value at 0. So that's what we call a present value in chapter 2. So how can you calculate the present value? Right, so obviously we will do discounting, right? So in order to go from future to present, we discount. So now let's start use different color to discount them back. For the first payment, in order to discount, I will need to times by V, V is the 1 year discount factor, right? How about the second one? So it will be V squared because the second payment is to be made at time 2. So in order to discount it from year 2 to year 0, I need to multiply by the 2-year discount factor, which is V raised the power to the second. So you know what you need to do, right? So it will be V cubic. So it will be V cubic. Okay, finally the last one. Okay, so I don't draw it. I simply write it Vn. So in order to prove, what we do is we first do the discounting, okay, and then after the discounting, all of them are the values at time 0. Finally, I can sum them up. Remember what I have been telling you? You cannot directly add or subtract values at different times. Okay, so in order to figure out what's going on, you must convert all of them to the same time point. Then you can add, you can subtract, you can do calculations. So what I want to so here this result is really the first dollar become V, the second dollar become V squared, the third becomes V cubic, goes all the way. The last one is V to the nth power, okay? Because I need to discount back n years. What do we have? It's a geometric. Now I hope you are further convinced the purpose of studying the previous video, right? Why I insisted that it's important to study some mathematics. So now here it's a partial sum of a geometric series, right? The first term is V, and the common ratio is also V. So I know this is 1 minus the common ratio, which is V. On top is the first term, which is also V. 1 minus the common ratio raised to the power of n. Here n is the number of terms to be summed up. So here I have obviously n terms, right? There are n payments. Okay, so this is the result. And it does not look exactly what we have. So if you want, you can simplify. What is the discount factor? Discount factor is simply the present value of $1 from 1 year discounted to time 0. So it will be $1 discounted by ABF, right? So here let's keep this one. 1 minus this term will become, I divided by 1 plus I. Okay. So obviously we can times by 1 plus I on for both, right? To remove it, then it becomes 1 minus Vn divided by I. Okay. Technically, there are so many formulas throughout this chapter. I wouldn't recommend you to memorize any of them. Okay, so deriving them takes 10 seconds, and once you are able to derive the formula, you can easily come up with this formula in 10 seconds, even 10 years, 20 years from today. But if you memorize this formula, or if you try to memorize this formula, you may not be able to survive the exam. You may forget before the first exam. So, but it's up to you, right? It's many people they rely on memorizing formulas to pass exams, and obviously that's not something I recommend. Nevertheless, you do have the choice, right, to hard memorizing everything. There is a trick, again, that is not mathematically justified, but it helps. So remember, this is the present value of annuity immediate. So you divide by I, right? Some people say this is immediate, right? So this is the first letter of annuity immediate. That is not wrong, right? But again, that's not the mathematical reason why you divide by I. Okay, that is the present value. What if you want to know the accumulated value? Uh, you may hear me use future value. Okay, so in my terminology, they mean the same thing. The textbook is more likely to use accumulated value because that is AV. We use AV in this textbook, but it is equally common, actually more common for people to use future value, FV. Okay, so this is, if I go back to my graph, A angle N is the value at 0. What if I want to know the value at N? That is the accumulated value or the future value. So how do I calculate this? How do I calculate the future value or the accumulated value? Right? I already know. In this case, I don't need to draw anything complicated. I only need to consider 0 and N. This is the value at 0, which we just did, right? And we want to know the accumulated value at time N. That is read as S angle N. So here the interest rate is I, so I write S angle N at I. This is nothing but the starting value, A angle N times AVF. Right, this is AVF for N years, right? It's, so once you have this, it will be 1 plus I to the nth. Okay, next, what is the next term I claim is 1, right? That's exactly 1 because V is 1 over 1 plus I. So 1 plus I to the nth will cancel the other 1 plus I to the nth, so you get 1. So this is the formula. If you want, well, again, you should, or I expect you to derive this in 10 seconds instead of memorizing it. Example, there's an example 2.1. 2.1, determine the present value. So when you read the question, please make sure whether this is present value or accumulated value you need to solve. Present value of regular payments of $50. So the size of payment is not 1, it's 50. So we will need to times by 50 to be made at the end of each of the next 15 years. At the end of the year, so it's annuity immediate. For the next 15 years, so you know the let's put X for the size of the payment, $50, and the number of payments is 15, and the annual effective interest rate is 10%. So my I is 10%. And I want to know the present value. So what I'm trying to calculate, my bad. So it's A angle N. So if you want, you can put 15 if you want. So here is 10%, or you can keep I if you want. Okay. This is my suggestion to you, right? Whenever you read a question, convert the number to our standard notation. And finally, write down what you want to calculate. So of course, you know, this is at the beginning of the course. I'm trying to show you every single step. Once you get more familiar, of course you can skip, but still, you know, it only takes 10 seconds to write everything down, and it's going to be a wonderful habit. Will definitely help you in the SOA exams. So if you want to write down the formula, it will be 50 times 1 minus the discount factor is 1 plus I. So, if you want, you can write 1.1. And since you discount, so it will be the negative power. So it's negative 15th divided by I because it's annuity immediate. So it's rather simple, right? So please make sure you are able to solve a question like this. There will be several questions like this in the first exam, right? So if you are able to solve those, you will at least pass this course. 2.2, it's pretty much the same question, except now you need to determine the accumulated value at time 15 years. So whatever you calculate here, what is the value? I think it's about $380 plus 30 cents. Okay, now you want to know the accumulated value. So what you do is 1 plus I to the nth. Right? It's simple, right? So once you know the result from the previous example, all you need to do is to times by the AVF. Okay, then you will get the future value. Of course, we do have the formula down here if you are really a formula person. Okay, that is the very first type of annuity we started, and it's not that bad. So it's a rather straightforward competition leading to very nice results, and obviously SOA questions will not directly ask you something like example 2.1 or 2.2. It will always be mixed with something else. But nevertheless, this is the foundation of annuities. And once you truly understand everything else, it's generalization. Second, annuity-due. Annuity-due is something highly similar to annuity-immediate, except that now the payments are made at the beginning. So it's the beginning of the year. So that's why I put the payment time to be 0, 1, 2, all the way to n minus 1. So if I go to annuity immediate, what is the time? 1, 2, all the way to n, right? So the time of payments is to be moved ahead by 1 period. So that's why it's at the beginning. We have a new notation. So you put 2 dots on top for the present value, and you should pronounce it as a double dot angle n. It's rather awkward, right? So actually you are supposed to memorize this notation, because on the SOA exam they will directly give you this or directly ask you to compute without specify the meaning of it, right? So for example, they will ask you, what is this? So upon seeing it, you should know you are supposed to calculate the present value. Okay, and this is the present value of annuity due. So when you see 2 dots, that's annuity due. Okay. I directly give you this formula because I would hope that, or I would expect, it's rather straightforward. We already did A angle N. What is the difference between A angle N and A double dots angle N? Let me use 2 different colors to draw the graph. Okay, 1, 2, all the way to n minus 1 and n. So above this timeline, I use pink color to denote it's annuity immediate. Okay, I mean, if you want, you can put the arrow up. It's up to you. Okay. So okay, but for annuity immediate, let me use a different color. So the payments are moved forward by 1 year or by 1 period. See, it ends at n minus 1. So the last payment will be made at the beginning of the final period. Okay. So once you do this, what is the difference? Right? You can think this way, link this. Right? So the payments in blue will be paid 1 year ahead of the corresponding payment in pink. That means when I do discounting for each one, the number of years to be discounted will be exactly one less for the blue, right, than for the pink. So that being said, my A double dot angle N is nothing but the previous one times by 1 year AVF. That is exactly the difference, right? If this payment times by 1 year accumulated factor, what I get is exactly the blue one, right? When you do the discounting, okay? So that's why, once you have the first formula, this one is very straightforward, okay? Of course, we don't need that. It's a simple mathematical proof. Let me borrow the space from below. Okay, so if I want to directly calculate this, the first payment is already paid at time 0, so there's no need to discount. The second one, I discount by 1 year. The third one, I discount by 2 years. Okay, and obviously, this goes on and on. The last one is n minus 1 because, again, it's paid at the end of n minus 1. So when I discount back to time 0, the power goes to n minus 1 instead of n in the pink case or in the annuity-immediate case, right? So obviously, this is pretty much the same, except my first term is 1 instead of v. Right? Still, I have 1 minus v to the nth power. So if I want, I can leave here, or I can plug in the definition for v, because v is nothing but 1 over 1 plus I. Right? So I can have this 1 minus vn divided by I divided by 1 plus I. Okay. By the way, this is D, right? This is how we define D. Okay. The nice thing when you connect this with the previous one is, in the previous case, you divide by I, and I is the initial letter of annuity immediate, right? Now we are dealing with annuity due. The first letter of due is D, so you divide by D. That is the trick, some book mentioned. I'm not sure whether our book mentions it, but anyway, if you want to memorize, that might help you. But nevertheless, it's very easy to derive the formula. So again, if you want to know the future value, or if you want to know the accumulated value, that is S double dot angle N, all you need to do is to times by the same factor, n year AVF. Okay, here let me mention one important remark. Sometimes people get confused. Is that here? So it doesn't matter whether we consider annuity immediate or annuity due. Whenever we talk about present value, it's at time 0. Okay, it's not at time 1, even it is annuity due. Okay, even for both annuity immediate and for annuity due, whenever we talk about the present value, it's going to be the value at time 0. And when we talk about the accumulated value, it will always be the value at the end of your sequence. is n, although we know for the annuity due, the last payment is actually at n-1, it's not at n. But when we talk about accumulated value, we refer to the very last time of the entire payment sequence, okay? Because our understanding is the last payment is made at the beginning of this year. So at the beginning, right? So although it's the point circling is at n-1, but you think that point as the beginning of the last period n. So when we talk about accumulated value, it is still at n, not n-1. Okay, so that is why when I move from present value to the future value or to the accumulated value, I times by 1 plus I to the nth power. Okay, keep in mind of that. Of course, this is straightforward. Example, we do have example 2.3 and 2.4. Let's take a look at 2.3. I will leave 2.4 to you. Find the present value. So we want to know present value. So it's A of 25 regular payments. 25 regular payments. So we know the number of payments is 25 of amount 3,500. So we know the size of payments is 3,500 at the beginning of each year. So we know this is an annuity due starting now, and we want to know the present value. So the annual effective interest rate is 9%. What I want to calculate is the present value, so it's A double dots angle N at I. Okay, so if you want, you can apply formula. So it's 1 plus V. V is 1 plus I, 1.09 to the, well, here is negative power. If you want to calculate the present value, negative 25. So it will be I divided by 1 plus I. Okay, use calculator to finish this example. What is 2.4? 2.4, you want to know the accumulated value. So I will leave that to you. So that marks the end of this video. In the next one, we will continue to 2.3, deferred annuities.